Okay, so here we are. I think I can finish 1.8 today. And if I finish 1.8, I'll go back and review some of the other problems that you might have from the previous sections in preparation for the test on Friday. Okay, so quick review of a lot of stuff. And hopefully you got a chance to look at my announcement on Canvas about the exams. I'll hit the highlights again, but look at what it has there. So what do I turn in? You say you turn in all of this stuff, anything that says skip it. There's that 70% requirement. You have to turn in at least 70% of the homework. So if you don't turn in at least 70% or you don't turn anything in, I do not grade your test. It'll count as a 0. Again, in my opinion, it's not that hard to get 70% because how much did I do, right? I did what, 1/3, 1/4, maybe even half of the homework. Okay, so it shouldn't be that hard to have 70%. Ideally, you do 100%. You know, that's the best case scenario, but you know, sometimes you might miss something here or there. That's why I say 70%. I don't really look at the homework for accuracy. I just check to see that you did it. Okay, so turn this in. So let's see, what else did I put on that announcement? So right at about 9 o'clock or so on Friday, I will either email you or I'll put the test on Canvas. So you have it there. You can open it up, and if you want to print it out, you may print it out. But even when we start at 9:10, I won't bother calling a row. That's just going to take too long. I want you to have time for the test. And so at 9:10, I'll even show you the test. So I'll, you know, show you the test right here. I'll show you all the questions. It might take 2 or 3 screenshots, or if you want to use your cell phone, you can do that. And let me see if I have an example. Yeah, here's an example of a test. It obviously doesn't belong to us, but I would just project something like this. Okay, so it might say this doesn't apply to us. Ignore name, row, and seat. If we had met on campus, I would want to know where you're sitting, what row and what seat. That obviously doesn't apply now. Show all your work, blah, 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 blah. Okay, so I usually give about 10 questions. Looks like this class that I had was 10 questions. So I might hold it like this for 15 seconds and say, okay, you guys do a screenshot or get out your cell phone and take a picture. And then I'll scroll down for the rest. Okay, then take another screenshot or take a picture on your cell phone, and that's it. But I'll also, at 9 o'clock, I'll either email it to you or put it on Canvas. So you have a couple of ways that you have it. Okay, so yeah, as far as cell phone is concerned, I know I put down in the syllabus, no cell phones allowed. That wasn't the assumption that we were meeting on campus, but we're not. So you can use your cell phone only for looking at the test questions. Now, if I see you, going like this, you're going to make me suspicious that you're texting somebody for the answers and whatnot, right? If I see you furiously doing other stuff on your cell phone, maybe you're looking up the answer. You can't do that. Okay. I preferred again that you have your camera set back where I can see your work, I can see your hands, I can see your surroundings. So in order for me to see your surroundings, so have your video on, but you're muted. Okay, no audio. Everybody doesn't want to hear what's going on there, and have your regular background. So please take off any fancy backgrounds like Golden Gate Bridge, or it's all green, or you got outer space or some other fancy design. Please, I want to see the actual background, please. Okay, so during the test, let's do this. If you have a question during the test, send it to the chat. Don't unmute yourself because that's going to disturb everybody else, of course. So if you have a question during the test, just send me chat, and I'll try to get back to you as soon as possible. Okay, so when class is over at 10 o'clock, and by the way, if you finish early, that's great. But at 10 o'clock, I'll turn off the class as usual. Then you have 5 minutes, 5 minutes to submit your exam. So just get out your cell phone, and just, click, 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 take pictures of all that and send it to me just like the quizzes. So you have practice doing that now, right? You've already had a couple of quizzes and you know how to send me the quiz. So just do the same thing for the test. Take a picture of every page, or if you have a scanner, scan it. And I need that by 10:05? Yeah, so class ends at 10, right? So firm deadline, give it to me by 10:05, and you have until 10:30 to submit your homework. Now, if you want to submit the homework earlier, like early in the day, like 7 o'clock or 7:30, just to get it over with, that's fine with me. So yeah, but I know the homework is longer, so take more time. Click, 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 click for all your homework. I don't know, maybe you got 10 pages of that, so it might be a little bit longer. So send that to me. But if you want to send it early, earlier that day, that's fine. Please don't send it earlier than Friday. I don't want to get it too early. But Friday before, let's just say anytime Friday before what? Before 10:30 a.m. for submitting the homework. Okay, so that's how that works there. And what else? You can have one cheat sheet, right? So one sheet of paper like this, 8.5 by 11, both sides. But after that, you're not supposed to use, people, computers. Don't use your cell phone except for looking at the problems. You can't use your notes. You can't use the homework except for that one cheat sheet that you have. Okay. All right. So that's as much as I can remember. If you have further questions, you can ask me later or send it through the chat. But I want to go on with our stuff today. So again, I might finish early today, and if I do, I'll go back and review some of this stuff. Okay. So assuming I finish okay today, your assignment for tomorrow is to ask me questions. So it'll be a question and answer day. So be prepared to ask me stuff. It's kind of like a glorified office hour tomorrow, okay? So you can ask me stuff from anything in chapter 1. But if that stops, if you don't ask me stuff after a while, I'm not just going to dismiss the class. I'll get started with chapter 2. Okay, so I guess the strategy is if you don't want me to do any chapter 2 stuff, then ask me lots of questions from here. Okay, so Friday's a test. Monday's a holiday, no school at all. Not just for me, but for all of CSM, Labor Day. So I thought it's a good time to give the test, and we meet again on Tuesday. Is that right? Okay. All right, so I think we're ready. So let's go ahead and do some stuff now. Okay, so 1.8, again, page 73. Use a quadratic formula to find any x-intercepts of the parabola. Y equals 6x squared minus 5x plus 1. So 23 through 28 are the same type. So I think I'll just show you one of those. It's not that hard, I think. 23. Y equals 6x squared minus 5x plus 1. Okay, it asks for the x-intercepts. Now remember, x-intercept means y equals 0. What does y-intercept mean? X equals 0. Right? So anytime the question asks for x-intercept, plug in y equals 0. If it asks for the y-intercept, plug in x equals 0. And again, if you want to put that in your cheat sheet, you may. Okay, so I put y equals 0. It says throw it in the quadratic formula. Okay, so my a, b, and c are 6, -5, and 1. So x equals negative b, negative 5, plus or minus the square root of b squared. -5 squared is positive 25. Okay. I think some of you already caught this drift before, but this b squared is always going to be positive. It doesn't matter if b is positive or negative or 0. When you square it, right, it's going to be positive. Minus 4ac by formula. 4 times a, which is 6, times c, which is 1. Again, if you've forgotten the quadratic formula, I'll let you put it in a cheat sheet. Although if I were teaching traditionally and we had met face-to-face on campus, I wouldn't be letting you have that. But we're supposed to slack off on you guys a little bit because of the situation we're in and COVID and all that stuff. So if you want to write down the quadratic formula, you may. All over 2a, 2 times 6. Okay, so this is 25 minus 24. 25 minus 24 is 1. So I have 5 plus or minus the square root of 1 divided by 2 times 6, which is 12. Well, the square root of 1 is 1. So 5 plus or minus 1 all over 12. Okay, so 5 minus 1 is 4. 4 divided by 12 gives me 1/3. And then 5 plus 1 is 6. 6 divided by 12 reduces to 1/2. All right, so as points, we're supposed to write it as points. Now, you don't have to graph it, but as points, remember that we have y equals 0. So the y coordinate is 0, and my x coordinates are just going to be 1/3 and 1/2. So there it is, 1/3 and 1/2. And that's about it. Okay, yeah, quick reminder for the quadratic formula if you want it. It's on page 70. And there we go. You've all seen it before. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you have the equation in standard form. Standard form means ax squared plus bx plus c equals 0, right? Okay, next one I'm going to show you was 31. Find a function whose graph is a parabola with vertex 1, 3, and that passes through the point negative 2, 5. Okay, vertex is 1, 3, passes negative 2, 5. Okay, so the vertex is 1, 3. Now, negative 2, 5, very crudely is over here. That means I know the parabola opens up. It opens upward. Okay, never mind about this, I messed up. Okay, so I know the vertex is 1, 3. I set it up like so. Okay, some coefficient a times x minus 1 squared plus 3. Okay, so you recall if I have ax squared, the vertex is 0, 0. But the vertex got translated, moved to 1, 3. Okay, so I'm going to move 1 to the right. 1 to the right means x minus 1 squared. And then 3 up is plus 3. Okay, so one more time. The standard ax squared, vertex is at the origin. They told me the vertex got moved to 1, 3. So I translate, move 1 right, 3 up. So 1 right means change x to x minus 1 in parentheses. And then 3 up means that. Okay, so now I have a parentheses x minus 1 squared plus 3. A is some coefficient. Okay, and now how do I figure out that a? I use this information. They told me it goes through negative 2, 5. So I plug in negative 2 for x, 5 for y. And you say, where's y? I don't see y. Y is equal to f of x. Right? So this whole thing here, that entire thing is 5. And put negative 2 here. And now it looks like that. Just ignore that. So since it goes through negative 2, 5, then negative 2 right here. And 5 replaces that f of x. So 5 equals a, parentheses, negative 2 minus 1 squared plus 3, and then I do some algebra. Okay, so right here you put the 5, right here you put the negative 2, because we know it goes through negative 2, 5. Okay, never mind about that, I messed up. Never mind about that, I messed up. Okay, so negative 2 minus 1 is negative 3, right? And negative 3 squared is 9. So I have a times 9 plus 3. Well, a times 9 is like 9a. Subtract 3 on both sides. 2 equals 9a. Therefore, a is equal to 2/9 divided by 9. Okay, so the function is f of x equals 2/9 x minus 1 squared plus 3. I'm not crossing that out. I had bad aim. I was supposed to draw the line underneath there. So this is the answer, 2/9. I was supposed to draw a line like that, but I aimed funny. So this is it. It's not a cross out. 2/9 x minus 1 squared plus 3. Okay. So there we go. All right. So that is that one. Okay, next one I'm going to show you was 33a, more about domain. We've done quite a bit of domain stuff. Find the domain of the function. Okay, so I'll do A, I'll let you do B. I'll just say quickly for a hint for B, factor out the x. B, factor out the x. Okay, A, square root of x squared minus 3. Okay. So I think we've played that game before. So there's a square root. What has to be true about square roots? Square roots have to be greater than or equal to 0. So I set x squared minus 3 to be greater than or equal to 0. So I lay down my boundary numbers. First I have to find out what makes this expression 0. So I solve, I move this over, x squared equals 3. That's a 3 there. X squared equals 3. X equals plus or minus square root of 3, which on a calculator is about 1.7. Okay, so if you punch out the square root of 3, how about I do it in this fairly elementary calculator? So I hit 3 and then square root button, which is over here. 1.732 blah, 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 blah. Okay, so I'll round it up to 1.7. So on my number line, negative radical 3, positive radical 3, which is negative 1.7, positive 1.7. Okay, assume we don't know the sign chart yet. They're both closed circles because I have a line underneath here. You can see that if I plug in radical 3, right? What is radical 3 squared? 3. 3 minus 3 is 0. So 0 greater than or equal to 0 is true. Same thing for negative radical 3. Negative radical 3 squared is 3. 3 minus 3 is 0. 0 is greater than or equal to 0. Notice if I didn't have that line underneath it, it would say 0 is greater than 0. That would be false for both of them. So they're both open. Okay, then I do my sign chart. So pretend we don't know this yet. Okay, so pick something in region 1, 2, and 3. And that's where you have to know this is about negative 1.7. So on this side it would be negative 2. Something in the middle is 0. Always pick 0 whenever you can because 0 is pretty easy to do math on, right? And positive 2. Okay, plug in 0 right here. 0 minus negative 3 is greater than or equal to 0. I'm sorry. Plug in negative 2, my bad. Negative 2. Negative 2 squared is 4. 4 minus 3 is 1. 1 is greater than or equal to 0. That's true. So I shade in region 1. Region 2, plug in 0. 0 minus 3 is negative 3. Negative 3 is greater than or equal to 0. That's not true. That's false. So I do not shade in region 2. Region 3, plug in 2. 2 squared is 4. 4 minus 3 is 1. 1 greater than or equal to 0. That's true. Shade in region 3. Okay, so I'm going all the way to the left. That's negative infinity, comma, negative radical 3. You should write it as negative radical 3. Don't put 1.7 in your final answer because 1.7 is only an approximation. In mathematics, we prefer to be as exact as possible. The only way you can be exact is to just leave it as negative radical 3. Bracket, because you're including negative radical 3. And since there's another region, U for union, bracket, because I'm counting radical 3, comma, and I'm shading all the way to the right, so infinity. And recall that negative infinity and positive infinity always use parentheses. Negative infinity is always on the left side. Positive infinity is always on the right side. So there's my answer. Okay, next one I want to show you was 39. A little bit of a word problem. A company that produces computer terminals analyzes production and finds it should make a profit P of X in dollars for selling X terminals, and here's the formula. Negative 0.1 X squared plus 160 X minus 20,000. How many terminals should be sold per month to produce a maximum profit? What is a maximum profit? Okay. Here's the profit function. Okay, so here's the strategy. Look at this. It's going to be a parabola. Look over here. Does this parabola open up or down? It goes down because of the minus. That means it looks generally like that. Okay, therefore, the vertex will be the highest point or the lowest point. It will be the highest point, the maximum. Okay, so they're saying in this problem, how do you find that maximum? Okay. All right, so I'm going to give you another formula. The book doesn't really go over that well, so put this in your cheat sheet if you've never heard of it. Okay, V stands for vertex. If you have standard form like this, ax squared plus bx plus c, right? So maybe I'll write that for you. Okay, so this is going to be a, b, and c. Now, one way you can find the vertex is to complete the square, but I'm guessing most of us don't like to do that. Okay, so if you have ax squared plus bx plus c, the vertex formula is x equals negative b over 2a. That's how you find the vertex. It's at x equals negative b over 2a. If you've never heard of that, go ahead and put that in your cheat sheet. That's how to find the vertex. Frankly, you've seen that before, right? That looks like just a portion of the quadratic formula, right? You know how the quadratic formula goes negative b plus or minus blah, 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 blah over 2a? If you just ignore that plus or minus square root, this is what you would have. Okay, so once again, the formula for the vertex of a parabola written in this fashion is negative b over 2a. So it's negative b, negative 160 over 2 times a, which is negative 0.1. Okay, you have a double negative. So negative divided by negative is positive. So I have 160 divided by 2 times 0.1 is 0.2. Punch it in your machine and you get 800. Okay, so the X value that maximizes the profit is 800 terminals per month, according to the word problem. And what is that maximum profit? So how many terminals should be sold per month to produce the maximum profit? The X coordinate is 800. Then it says, what is the maximum profit? Just plug in 800, and I'll just leave that to you. Okay. So plug in 800 right here. 800 right here. So negative 0.1 times 800 squared plus 160 times 800 minus 20,000. Just punch it in a calculator. That gives you the maximum profit. So that's it. Okay. All right, then 45 is the last one that I was going to do, and then I'm basically done after that. Okay, so 45, and again, we're only doing A and B. It's A, B, C, D, all the way out to G or whatever. Okay, we're just going to do A and B. Okay, a driver driving on an interstate highway sees traffic coming, blah, blah, blah. The speed is V of t equals negative 4t squared minus 4t plus 80. Make a sketch of the speed curve for t greater than or equal to 0. Okay, I mean, you don't have to do that much. Okay, which way does this parabola open? Opens down, right? So I know it's going to go down. It says t is greater than or equal to 0. So I just plugged in some numbers. Okay, I plugged in 0. 0 there is 0. 0 there is 0, so I get 80. So 0 gives me 80. I plugged in 1. Put a 1 here. That's negative 4. Put another 1 there. That's another negative 4. So negative 4 minus 4 plus 80. Well, that's like 80 minus 4 minus 4. That's 72. It's dropping. Plug in 2. I won't bother you with that, but if you punch in 2 here, you get 56. It's falling, etc. Okay, so it looks something like that, very crudely. I've got that. Okay, then part B. How long does it take for the car to come to rest? Okay, now if an object is at rest, what's the velocity? 0. So I set this equal to 0, right? Car is at rest. Something is at rest. You are at rest. That means your velocity is 0. So I just put a 0 there and solve. So I solve 0 equals negative 4t squared minus 4t plus 80. Factor out a negative 4. If I factor out negative 4, it becomes t squared plus t minus 20. Change every sign. Okay. The minus signs means the signs are opposite. One's a plus, one's a minus. Coefficient of t is 1. So I'm thinking of two numbers. What two numbers have a product of 20 and a difference of 1? That's 4 and 5. So 4 and 5. In order to come up with a positive, positive goes with a 5, minus goes with a 4. You can FOIL it back out. Then I use the 0 factor property. Either this is 0, impossible. Negative 4 can't be 0, they're different. Or this is 0, or this is 0. So what number makes this 0? 4. What number makes this 0? Negative 5, but we throw it out because they said t was greater than or equal to 0. That usually makes sense. In most experiments, like science experiments, you start off with t equals 0, and you only go forward, like 1, 2, 3, 4. You don't usually go backwards, like -1, -2, and so on. So t is equal to 4 seconds. And that's about it. Okay, so I'm actually done with the lecture, folks. I've done everything I wanted to do here. Okay. So coverage for the exam is all this. And for the remaining class time, I'll try to go back and do some problems that some of you asked before, and I thought I'd share it with the rest of the class. Or some of them I may have already done, but maybe stop. I'm going to go back and do them to their conclusion. Okay, so I'm going to go all the way back to 1.2 right now and go to 1.257. Some of you had some questions about 1.2 stuff. So 1.257, let me try to finish that. I think I just set it up. 1 over x is less than or equal to 5. Okay. And the whole idea, where they even give you the hint, make sure that this side is 0. So I'll show you how to do that now. So 1 over x is less than or equal to 5. And I know that x cannot be 0. That's definite from here. Okay, so how do I get this to be 0? Subtract 5. So 1 over x minus 5, that's like 5 over 1, right? Now I need a common denominator. What's the common denominator here? X. So multiplied by x over x. So one more time, I subtract 5 on both sides to give me a 0. I need a 0 on this side. And so my common denominator is x. The top now becomes 1 minus 5x. So on my number line, I put down whatever makes the top 0, whatever makes the bottom 0. What makes the bottom 0? Well, 0. The top, a little bit of algebra. 1 minus 5x equals 0. I trust you can do that. X is equal to 1/5. You know, you can add 5x, divide by 5. You get 1/5. Okay, so I put down 0 and 1/5. Now, I exaggerated my number line. In reality, these two are pretty close, right? 1/5 is pretty close to 0, but I just open it up since I don't need any more space anywhere. And now what about the open or closed 0? Okay, 0 is open because you're never allowed to divide by 0, right? If I put a 0 here, I'm dividing by 0. That's automatically a mathematical no-no, so don't do that. Now, why do I have a closed circle on 1/5? So plug in 1/5 here and 1/5 here. What is 5 times 1/5? 5 times 1/5, the 5s would cancel out, leaving me with a 1. So I have 1 minus 1, 0. So 0 divided by that is 0. It would say 0 is less than or equal to 0. 0 is less than or equal to 0. That's a true statement. Okay, so 1/5 is a closed circle, but 0 is an open circle. And now region 1, 2, and 3. Okay, so what's on this side? I pick -1. What's on this side? +1. How do you find something in between 0 and 1/5? Okay, so what I did was I thought of this as a decimal. 1/5 is 0.2 as a decimal. You can divide that out in your calculator very easily. So 0 and 0.2, that means between them would be 0.1. I plug in 0.1. That's all. Okay, so now I plug in -1. So 1 minus 5 times -1, that's a double negative, so it's positive. So the top is positive. The bottom is -1, it's a negative. So I have a positive divided by negative, which is negative. Is a negative less than or equal to 0? Yes, that's true. So shade in region 1. Point 1. 0.1 in the bottom, that's positive. What's 5 times 0.1? 5 times 0.1 is 0.5. So I would have 1 minus 0.5. That's like saying 1 minus a half. That's positive. So I have a positive divided by a positive, which is positive. Is a positive less than or equal to 0? No, that's false. So do not shade in region 2. And region 3, 1. Put a 1 here and here. 1 on the bottom is clearly positive. 1 right here, 1 minus 5. 1 minus 5 is a negative. So that gives me negative divided by a positive. That's a negative. Is a negative less than or equal to 0? That's true. Shade in region 3. So final answer, negative infinity, comma, 0, parenthesis, paren because I'm not including a 0, union, bracket, because I'm including 1/5, bracket 1/5, comma, infinity. And once again, negative infinity and positive infinity always have parentheses, with negative infinity on the left side, positive infinity is always on the right side. Okay, 59. I was just going to give you the setup for 59. Still section 2. Show that to you here. 59. Yeah, 2 over x minus 1 greater than or equal to 3 over x plus 2. 1.2, page 13. Okay, so again, move this over. So I subtract this over. 2 over x minus 1 minus 3 over x plus 2 is greater than or equal to 0. Okay. Now, there's supposed to be a minus here, but there's a reason why I changed it. Okay, so pretend there's a minus temporarily. Okay, now I need a common denominator. So you multiply this side by x plus 2 over x plus 2. Multiply this side by x minus 1 over x minus 1. Okay, now when it comes to distributing, okay, keep in mind there's a minus here. What I did was change this to a plus and put the negative here. Okay. I find this helps students often to remember to distribute. You have to distribute negative 3 to the x and the negative 1. So one more time, it was supposed to be a minus sign and a positive 3. But I think it's easier to remember to make this a plus and put the negative 3 here. I just find from experience, if you put the minus here, some students will forget to distribute the negative 3. Okay, so it's 2x plus 4 minus 3x minus 3 times negative 1 is a positive 3. Okay, so that ends up being 4 plus 3 is 7. 2x minus 3x is a negative x. So you have 7 minus x over x plus 2, x minus 1 is greater than or equal to 0. Okay, so I say etc. Work it out like the previous problem. Although it's easier, you don't have any fractions. So what do I lay down on my number line? Whatever makes the top 0, whatever makes the bottom 0. What makes the top 0? 7, negative 2, and 1. So 7, negative 2, and 1 on the number line. And I just say etc. You try to finish the rest of that from there. Okay, then I wanted to show you 77. Some of you asked about 77. So where am I still? 1.2, page 13. You are contemplating, that means thinking about, if you don't know what contemplating means, big word, $50,000 between 2 different investments. One is 5%, the other is 9%. You need a return of at least 7.5%. What is the maximum amount of the money that you can invest at the 5% rate? Okay. So here's the idea. You have $50,000 to play around with, some at 5%, some at 9%. How much do I invest at the 5%? I decided to call it X. Now, if this is X, they have to add up to 50,000. Then the amount at 9% is 50,000 minus X. Okay, this is X, 50,000 minus X. Example, suppose I invest 20,000 here, then you know this is 30,000, right? They have to add up to 50,000. Or maybe it's 10,000, 40,000. Or maybe it's 1 and 49,999. right? They have to add it to 50,000. So how do you do that as a formula? You take whatever the amount is here and you go 50,000 minus that, right? So 50,000 minus X. Now, you need at least 7.5% return. That says 7.5% return. So that means 0.075 times the 50,000. That's the return. You want that to be greater than or equal to whatever this is. At least means you're happy if you have that amount, but if you have greater than, you're happy, right? So when we say at least, so if I say, somebody is at least 20 years of age, right? What does that mean? If you're at least 20 years of age, that means 20 or 21, 22, 23, and so on, right? Which means greater than or equal to. All right, so I take the investment at 5%, which is 0.05 times the X, plus the amount of the investment at 9%, 0.09 times 50,000 minus X, is greater than or equal to 0.075 times the 50,000, because you want at least 7.5% on the total. What was the total? 50,000. So 0.075 times 50,000. And again, this says at least. Greater than or equal to, translation means at least. So there's my setup. All right, so clean this up. 0.05x plus 0.09 times 50,000 comes out to be 4,500. Minus 0.09x. 0.09 times negative x is that. Greater than or equal to, punch it in your machine, comes out to be 3,750. Okay, subtract 4,500 on both sides. 0.05x minus 0.09x is negative 0.04x. Greater than or equal to, that minus that comes out to be negative 750. Divide both sides by negative 0.04, which is a negative number. So recall, if you divide by negative, inequality symbol reverses. So its x is less than or equal to 18,750. So in order to have at least a 7.5% return, okay, the amount I invest is less than or equal to 18,750 at 5%. So back in the original question, where'd it go? What is the maximum amount of money that you can invest at 5%? So the maximum I can invest, according to this, is 18,750. That's the max amount. That says maximum amount at 5%. And there we go. Okay. All right, so that is that. Let me see, try to fill in some other holes here. Go back and finish 1.361. Find the area of the region outside x squared plus y squared equals 1, inside x squared plus y squared equals 9, doing 1.3. Here was the picture. X squared plus y squared equals 1 is a circle, center of the origin. The radius is 1, square root of 1, which is 1. X squared plus y squared equals 9, center of the origin, radius is 3. So here's the picture. Radius of 1, radius of 3. The formula for the area of a circle is pi r squared. You only want this outer part, so I'm throwing out this. So I take the area of the outer circle, pi big R squared, minus pi little r squared. I'm throwing that out. So it's pi times 3 squared minus pi times 1 squared. 9 pi minus pi. Final answer is 8 pi. Okay. Yeah, going back to 1.2, 1.261. Absolute value of 5x minus 3 equals 2. 1.2. Show you that. Okay, let me cover this up. Absolute value of blah, blah, blah equals 2. So behind my pen, what numbers would make it a true statement? So behind my pen, if that came out to be 2, it's true. But it's also true if that came out to be -2, because the absolute value of -2 is also 2. So there we go. 5x minus 3 is equal to -2, or 5x minus 3 is equal to +2, like that. You just work them both out. Add 3, add 3. Same thing here, add 3, add 3. So 5x equals 1, divided by 5, x equals 1/5. This one, add 3, 5x equals 5, x equals 1. So my two solutions are 1/5 and 1. Quick double check. What happens when you plug in 1? 5 minus 3 is 2. Absolute value of 2 is 2. What happens if I plug in 1/5? What is 5 times 1/5? 5 times 1/5. The 5's cancel, leaving me with a 1, right? 1 minus 3 is -2. And the bars, absolute value of -2 is 2. So they definitely both work. Okay, and let's see. I'm jumping all the way to 1.741b. Sorry for jumping around, but these are some of the questions that some students ask. So you might, if another student asks for it, you might want to look at it again. 1.7, page 63, number 41. The average weight in grams of a fish is this. W of n is 500 minus 0.5 m. Okay. So express the total fish weight as a function of the number of fish in the pond. So all you do is multiply W of n times n. Okay. N is the number of fish. This is the average weight. What's the total weight? Well, I just multiply the average weight times the number. So you just take this thing and multiply it by n. That's about it. So the total weight is 500 minus 0.5 n times n. So there it is, 500n minus 0.5 n squared. And that's pretty much about it for that one. Okay, and let's see. Yeah, it's not so nice to graph it. Let's skip 41a, but I will talk about C. Okay, did I already say skip that? Maybe not. Okay, so 1.7, let's say, I'm running out of space here. Skip 41a. Yeah, some of you might say, I already did it. Okay, well, good. It's actually hard to graph. The graph was kind of difficult. So 1.7, let's skip 41a. Okay, I will talk quickly about 41c. What happens when n is greater than or equal to 1,000? Okay, if I plug in 1,000 here, 0.5 times 1,000 comes out to be 500. 500 minus 500 is 0. That can't happen. Okay, so we have something that's called, we have model breakdown. So 41c, we're just going to say model breakdown. Model breakdown, which means we can't use the model anymore. I mean, the average weight of a fish can't be 0 and it can't be negative. So we just say we have model breakdown. All right, so that's it. Let me stop the share. Okay, so that was all I have. We don't have that much time left. Let me quickly check the chat. Okay, so if we're done early, can we leave? Yeah, hopefully. Let's see. If we do not complete 70%, the test is not graded. Correct. You must turn in at least 70%. So if you don't turn in at least 70% or you don't turn in anything, I don't grade your test, you get a 0. All right, and let's see. Judging from the time, 2. Okay, I see some of you have other questions. I'm not sure if I have enough time to do that. We only have about 4 minutes left. 1.6, 45, and 49. Yeah. Okay. I know some of you asked questions. I don't have enough time to do it right now. Sorry. Maybe you can bring it up tomorrow. All right. So some of you in the chat, you asked me for some questions. We're pretty much out of time. So please ask them out. Anything quick, please, in the last minute or two? Checking what else. Okay. So tomorrow, I'm done with everything for lecture. So tomorrow, I'll let you have the entire class period for questions and answers. So think about what you have for questions. And if that stops, if you don't have anything, I'm just going to go on to the next chapter. So if you don't want me to do new stuff, then ask questions for the entire time. All right? Okay, so that'll do it for today, folks. All right, so have a good day, and we'll see you all tomorrow. All right, thank you. Bye.